Now for the main event, it's my distinct pleasure to introduce Jay Wright, class of '87, the Vice President and Treasurer of our Board of Trustees, to introduce our speaker today.
Thank you, Jeff, and good morning, everyone. And I'd like to echo Jeff and congratulate the varsity on a great game last night. They played terrific defense for those of you who weren't there, which wasn't many of you because it was a great crowd. I'm here this morning, and it's my distinct pleasure to introduce Phil Soucy. Phil moved to St. Johnsbury when he was 5 years old. He grew up on Concord Avenue with his parents and his 3 younger siblings. He went to Lincoln Street School, Portland Street School, and the old St. Johnsbury Junior High before enrolling at the Academy in the fall of 1965. Phil graduated from the Academy in 1969. He then attended and graduated from Norwich University in 1973 with an engineering degree and was commissioned a second lieutenant in the U.S. Air Force. But Phil was just getting started. A decade before Tom Cruise hit the big screen as Maverick, Phil Soucy was a Top Gun. Phil earned his wings as a weapons systems officer flying high-performance fighter aircraft. He attended the Air Force's version of Top Gun, as well as the Air Force Test Pilot School. He logged several thousand hours of flying over 30 different types of aircraft, including over 100 landings on aircraft carriers. While much of his activity flying airplanes for our country remains classified, some interesting details have leaked out. Phil is one of only a very short list of pilots to ever fly the SR-71 Blackhawk, the fastest airplane ever built, which flies at more than 3 times the speed of sound. More people have flown the space shuttle than have flown the Blackhawk. As a crew member, he was directly responsible for flight testing advanced upgrades to the SR-71. His work was dangerous. Over 40% of the Blackhawks either crashed or had severe mechanical errors due to the intense speed and high altitude at which the plane flew. As a reconnaissance plane, the Black Hawk was also a target for the Soviets back during the Cold War, who would have loved to have shot down one of those advanced planes. After 20 years in the service, Phil retired and became an entrepreneur. He started an aerospace engineering company called Modern Technology Solutions, Inc., MTSI. Once again, Phil stood out. He has built MTSI to over 600 employees and more than $100 million in annual revenue, while again serving our country by providing vital support for the Air Force and other government programs. With all this success, Phil has not forgotten his roots. He is a member of the Board of Trustees of the Fairbanks Museum and Planetarium, is the incoming chairman of Kingdom Development Company, which focuses on economic development and online education here in the Northeast Kingdom, and is a generous donor to the Academy, Norwich University, and the museum. Please join me in welcoming back to the Academy a true American patriot, Phil Soucy.
Well, thanks so much for having me, and in the next 20 minutes or so, I hope to develop a little bit of interest in you. And you can see the title of my presentation. It sounds like I'm going to talk a lot about history, and I will a little bit, but probably a better title would have been My Passion for Aviation. And what I want to do is instill upon you maybe a little bit of interest in the area of aviation, because it's been a big part of my life. It's been a passion for me professionally, as well as in my personal life. When you think about aviation, man first flew a little over 100 years ago, right? 110 years ago, December of 1903, the Wright brothers, 2 bicycle builders from Dayton, Ohio, were the first to fly. They weren't highly educated, although they were engineers and technicians in their own right. They spent a lot of time reading the literature. This was a 3 or 4, almost 5-year effort before they actually got into the air. They read all the available literature that was out there. They studied what others had been trying to do and why they had failed. They built a wind tunnel. They built kites. They built gliders. They had hundreds of glider flights before they had their first manned flight. And that first manned flight, they had 4 flights on that day. That first flight was 120 feet long. It lasted 12 seconds. The airplane that you probably flew on, that you went to Florida on vacation or to visit some friends, had a wingspan that was probably longer than that first flight that they had. Their longest flight that day was 854 feet and lasted 59 seconds, but they were the first to get into the air and to fly. And I want to talk about this first 100 years of aviation, then talk about what's going on now and what the future might be for, and a role that you might be able to play in that future in aviation. So the Wright brothers were the first to get going. Shortly thereafter, though, it was only 10 years later, and Thomas Benoit thought, I can make some money with this. So he put in place the first airline, and that airline operated between Tampa and St. Petersburg, Florida, carrying 1 passenger in an open cockpit, 1 pilot, back and forth on a 27-minute flight, whereas opposed to, if you didn't take the flight, it took you all day to drive around the bay, if you're familiar with that area down there. So the first airline, 10 years after the Wright brothers first flew. If you move forward a few more years, you look at the Spirit of St. Louis up there. Charles Lindbergh, 1927. He was able to win the Orteig Prize. In the Orteig Prize, first of all, Charles Lindbergh was an air mile pilot, 25 years old. Orteig Prize had been set up by a New York entrepreneur offering $25,000 for the first individual or team that could fly nonstop from New York to Paris. $25,000, if you do the math on that as far as what it would be worth today, it's worth about $300,000. So $25,000 is a lot of money, but it was really a lot of money back then. And so he won that prize where others had failed. And others had failed that had significantly more resources, significantly larger teams, had significantly more experience, but Charles Lindbergh prevailed, and he was the first person to make that flight. Non-stop, by himself, in a single-engine airplane, 33 hours and 30 minutes. He landed in Paris and was immediately famous, and was famous for the rest of his life, and went on to have huge successes in the area of aviation. Jimmy Doolittle. 2 years later, Jimmy Doolittle broke another record. And that record was, and it was both he and a number of other aviation pioneers at that time recognized that aviation was not going to go very far if we couldn't somehow conquer some of the challenges of weather. If the weather was bad or if it was foggy, airplanes couldn't fly. Or if they did fly, they ran into trees, ran into the ground, became disoriented in the clouds. And so Jimmy Doolittle became the first person to actually conduct a blind flight relying only on instruments and on ground beacons. He was able to conduct a 15-minute flight to demonstrate the potential of totally blind flying. And that effort had been funded by Harry Guggenheim, a huge philanthropist, and he saw the potential of air travel and funded the efforts for Jimmy Doolittle. Jimmy Doolittle went on to be a World War II hero also, if you study war history. Amelia Earhart, second person to cross the Atlantic, 5 years later. So you might think that, well, Charles Lindbergh did this, and there must have been people doing it right after him. No, it was 5 years later, and Amelia Earhart was the second person to accomplish that. And she went on to have a significant career in aviation as well. Unfortunately, some 5 years later, she lost her life trying to circumnavigate the globe, was lost in the Pacific. The Boeing 307, the world's first pressurized airliner. So think about the Wright brothers, 1903, we're now up to almost 1940, and Boeing developed the world's first pressurized airliner. What does that mean? Now airplanes could fly higher, people didn't have to wear oxygen, they could be in relative comfort, we could carry a couple dozen people in an airplane at one time, fly above the weather at 20,000 feet, and go 225 miles an hour. The Boeing 307, the world's first pressurized airliner. A couple other advances were going on at that time. the Henry Ford of aviation, Bill Piper, Piper Aircraft Company. In the period between 1937 and 1949, 14,000 J-3 Cubs, the yellow aircraft on the right-hand side up at the top there, were built, giving aircraft to the masses. He was considered the Henry Ford of aviation. He ran the Piper Aircraft Company until 1970 and had a span of 50 years as the CEO, bringing aviation to the masses. The development of the jet engine. There was work going on in Germany in the early 1940s, but in Britain, Frank Whittle developed the jet engine that revolutionized the capabilities of aviation. And in the late 1940s and 1947, development by the Air Force and Chuck Yeager at the controls flew the Bell X-1 to supersonic speed, being the first man to fly faster than the speed of sound. So the next 50 years, hence you think that everything was accomplished in the first 50 years. What did that second half of that first generation look like? A number of significant milestones occurred as well. On the left-hand side there, the Boeing 367-80, Bill Allen, in the early 1950s, invested the future of Boeing Aircraft Company, $16 million, a significant sum today, and certainly in that time. He bet the future of the company on jet-powered commercial transportation and built the Boeing 367-80, demonstrated to the Air Force, demonstrated to the airlines, and that is what became the Boeing 307. In fact, if the airplanes that we fly in today are primarily based on that aircraft, a significant accomplishment. 1961, man went into space. It wasn't a U.S. astronaut, it was a Soviet astronaut, Yuri Gagarin. I was in the 4th grade at that time. This is 1961. And, the whole area of space opened up starting at that point. 1969, we're starting to carry more passengers and starting to fly faster. The Concorde shown there, as well as the Boeing 747. Boeing 747 first flew in 1969, and today there's over 1,400 Boeing 747s that have been built, current models carrying as many as 450 passengers. So quite an accomplishment if you think of where Thomas Benoit was in 1914 to where we are today in that class of aircraft. The Concorde, supersonic transportation was long a dream of man after first flight. And so British Aerospace and Aerospatiale developed the Concorde, an aircraft that could carry 100 passengers in first-class comfort at twice the speed of sound, 1,300 miles an hour, cutting the time that it took to fly between Washington and Paris, as an example, from 8 hours down to 4 hours, a significant accomplishment. And that aircraft remained in service until 2003, no longer flying. Man continued an exploration of space. 1969. Neil Armstrong and Buzz Aldrin stood on the surface of the moon. And I can vividly remember on July 20th, 1969, which is the year that I graduated from school here, the summer of my senior year after graduating, sitting over here on Concord Avenue in my parents' home with my 3 younger brothers and sisters and watching our black and white television and watching them walk down the steps of the lunar lander and stand on the surface of the moon. We were speechless. It was an exciting moment, and it was a proud moment to be an American to see what had been accomplished. Continuing in the space area, global positioning system. You all are young enough that you've seen it around and had it around pretty much your whole lives. But the first satellite was put up in 1973. The constellation became operational in 1995 with 24 satellites on orbit, providing essentially precision accuracy of where you are, and it's changed how we've done so many things from tracking of ships at sea to routing of package delivery services, et cetera. A significant accomplishment. Initially put in place for the military, but obviously with civilian applications as well. The Space Shuttle program, 1981 to 2011, 135 flights carrying hundreds of astronauts into space, between 2 and 7 astronauts into space at a time. 5 space shuttle vehicles built, 2 lost in accidents. The remaining 3 are in museums. Gossamer Albatross up there, Paul MacCready. Paul MacCready was a aerodynamicist. He was the CEO and founder of a company called Aero Environment. He was an amateur bicyclist. And he took on the challenge of developing a high-performance, human-powered aircraft that won the Kramer Prize. And the Kramer Prize, there was a couple different ones, but the second one I'm showing the Gossamer Albatross for, was to be given to the first team that could build a human-powered aircraft that could cross the English Channel. And they built the Gossamer Albatross with lightweight materials, efficient aerodynamics, and human-powered, essentially pedaling a bicycle and turning a propeller to cross the 22 miles of the English Channel in 2 hours and 49 minutes. A significant accomplishment. That occurred in 1979. Continuing with space exploration, the Mars Sojourner landing on the surface of the moon in 1979, a remote-controlled autonomous vehicle that was able to collect samples, analyze them on the surface of Mars, and send the results of that information back down to scientists and NASA here on Earth. A significant accomplishment. I want to, during this half century, I'm talking about the first century of aviation, but during the second half of aviation, I want to dwell just briefly, and at the end I have a video that'll show a little bit more about the SR-71. The SR-71, developed by Kelly Johnson, a revolutionary designer, a prolific designer. He designed a number of aircraft that saw service in World War II during the Cold War. It is the world's highest flying, fastest aircraft, and I had the privilege of flying that aircraft for a number of years. And when I talk about highest flying, fastest aircraft, over 3 times the speed of sound, 2,200 miles an hour, 85,000 feet at near the edge of space. And this aircraft flew first 50 years ago, a significant accomplishment for its time. Holds numerous world records that I'll point out in a second. A military reconnaissance aircraft, and as I mentioned, operational first flew in 63, operational 64 through 1998, and still holds the world's records for speed and altitude. Much had to be invented to make this aircraft successful. 32 aircraft were built. Jay mentioned some of the losses. 12 were lost due to accidents and mechanical problems. None were ever lost due to enemy action. Thousands of missiles were fired at this aircraft. Hundreds of intercept attempts by enemy fighter aircraft, primarily Soviet Union, tried to shoot down this aircraft. It had a very unique propulsion and inlet design system. Any jet engine has to get the air slowed down to subsonic speeds before it goes into the engine. So if you have air out there at 2,200 miles an hour, you have to slow it down to about 350 miles an hour before it can get into the engine. And the front end of that engine and that inlet was the secret behind accomplishing that. And this was all designed at a time before computers. Hard to imagine. Slide rules, probably never seen one, but slide rules, some basic calculating machines were all that these engineers had to accomplish this. 93% of the aircraft was built out of titanium. Even though at 85,000 feet, it's minus 67 degrees outside, the aircraft's surface gets up between 500 degrees Fahrenheit and 1,000 degrees Fahrenheit due to aerodynamic heating. That's just the fact that you're going so fast, literally faster than a bullet, that the surface of the aircraft heats up to those kind of temperatures, and it has to be built out of titanium because aluminum won't be able to handle the stress of those temperatures. Had a very unique navigation system with the aircraft. I won't go into the details of it, but it was able to track the stars and see the stars like a mariner at sea might do, and it could do that even in the daylight. It was sensitive enough that it could see the stars even in the daylight, and through triangulation of the star's position, able to determine where the aircraft was at. This aircraft operated before the times of global positioning system. Still holds the world's record. Aircraft 972, which is one of the aircraft that I flew at Palmdale. It was a test aircraft we had. It's now in the National Air and Space Museum in Washington, D.C. In fact, if you're ever down in Washington, I invite you to stop by and see it. I'm a volunteer docent there. I give tours. and you can connect up with me. I'd be glad to give you a personal tour if you're ever down there. You can find my information through Headmaster Lovett or the front office, and be glad to show you around if you're down that way. But aircraft 972 on its last flight to the Aerospace Museum set the world's record, doing what it did on every single flight that it flew, flying high altitude and high speed, flying from Los Angeles to Washington, D.C. in 1 hour and 4 minutes. And when you think about what it takes in a commercial airliner, at 500 miles an hour, that's a 4-hour-plus trip to do that. So lest you think that first 100 years, there's no more innovation going on, there's few challenges to undertake, let me tell you a little bit about what's going on now. And all this has been going on during the time that you have been in school, since when you started grade school to the present time, so it's relatively recent. Unmanned air vehicles such as Global Hawk are supporting the military, flying autonomous unmanned air missions. And so autonomous, there's no pilot at the control on the ground flying this. These things are programmed, they take off, they fly a mission, they come back. They're also being used by NASA to do Earth resources research, such as what's going on with large areas of forestry or whatever. How are things changing with time? Understanding that from high altitudes for long duration mission. The International Space Station is up there, fully operational. Half a dozen or a dozen or so astronauts operate in that environment on a continual basis. A significant accomplishment. Following on the heels of Sojourner is Curiosity. Curiosity landed in 2012 on the surface of Mars. It's obviously uninhabited autonomous vehicle. It's on the surface of Mars. It's about the size of a small car. So while Sojourner was much smaller, about this size or so, about the size of this podium, Curiosity is significantly larger, the size of a car landing autonomously on the surface of the moon. And that was after an 8.5-month trip to get there, taking off from the Earth, obviously, and landing on the surface of Mars after 8.5 months. That's 350 million miles from the Earth to Mars. And when it arrived on the surface of Mars, it landed within 1.5 miles of the target area. Just phenomenal when you think about the amount of time, the distance it had to go, and to be that accurate to arrive there. You can look on the NASA website. You can see the videos, the real-time videos. You can see data that's coming off of Curiosity and what they're accomplishing with that system. It's just truly phenomenal. Airliners continue to get more efficient and continue to get larger. The A380 Airbus shown there, being operated by a number of different airliners. If they configure that aircraft with fully coach seats, and you know how they like to cram them all together and give you minimum leg room, they can put 854 seats in the Airbus A380, and it's in service now. So when you think about what was going on with the Wright brothers and then where we are today in carrying passengers, it's just truly phenomenal. Felix Baumgartner jumping from the near edge of space, that occurred in 2012. Unless you think that was just some stunt that was done by Red Bull, yeah, they were the funding source and the marketeers behind that. I had an opportunity to meet some of the individuals that were involved with that project. That was a 3.5-year research effort with a series of practice and build-up jumps that went on into that. Significant amount of research went into developing the suit, the technology, the parachute, the capsule, the ability to accomplish that safely when he jumped from 128,000 feet and actually became the first human being to break the speed of sound at 1.25 Mach during his free fall. Significant accomplishment. Burt Rutan, a modern-day aeronautic pioneer. Scaled Composites is his company in Mojave, California. They have had a whole host of inventions and revolutions in aerospace. Their most recent endeavor was winning in 2004 the Ansani X Prize, $10 million given to the first commercial space venture that could be accomplished. So commercial manned space flight. Part of that, everything was done by NASA and the government with billions of dollars. So this challenge went out, $10 million for the first individual or private enterprise that could take this on. So flying Starship 1, they were able to win that prize. Burt Rutan, Scaled Composite, White Knight, and Spaceship 1. Commercial involvement continues to progress into the space area beyond just manned space flight. Now SpaceX, Elon Musk, entrepreneur, founder of PayPal, has taken his money and focused it on space ventures. So putting spacecrafts into orbit, supplying the space shuttle with cargo and bringing astronauts up there used to be the sole venture of NASA. Billions of dollars spent to do that. So now the government, though, is turning to private enterprise and saying, private enterprise, we're willing to pay money for you to carry our astronauts up there and carry our cargo up there. But we're not going to fund you to do it all. We want you to take it on as a business enterprise. So a number of companies are doing that. And so shortly, the government will be paying for, on a per-seat basis and on a per-pound basis, to get cargo to the International Space Station or into low Earth orbit. There's a couple companies doing that. One is SpaceX. The other is Orbital with the Cygnus space vehicle. They just rendezvoused with the International Space Station for their second time, I think, a couple months ago. So significant activities going on in that area. Commercial unmanned air vehicles continue to be developed and promoted. There's some challenges to operating in the National Airspace System, and the FAA is taking on those. There's some development work going on there. But when you look at unmanned air vehicles having the potential for fighting forest fires, for surveying forestry or agriculture, disaster relief, when you think about, look back at what happened a number of years ago with Katrina or in the aftermath of other disasters, unmanned air vehicles with high altitude, long endurance persistence can be of significant assistance. So what does the next 100 years look like? Lest you think that everything has been done or has occurred, there's still significant things going out there. And so 100 years is a long time from now. But when I think back over the last 100 years, I had the fortune of spending 40 years of my career during that. So 40% of that 100 years I was able to participate in. So your professional lives and your professional careers will span about half of this next 100 years, and the possibilities are endless. In the left-hand side, White Knight and Spaceship Two. So while the Burt Rutan and his team won the Ansari X Prize of $10 million by being the first man to go into commercial enterprise to put a man into space, they are now moving into space tourism. And so there are over 600 people that have paid full deposit, and it's a very expensive ticket at this point, but the price will eventually come down. But they have lined up for being able to buy a ticket to have the opportunity to be carried into space. And so Spaceship Two is currently flying now. It's flying out of Mojave, California. It's carried up by White Knight, that thing that looks like 3 airplanes lined up. It's dropped off. It's in test phase now. They go into suborbital space and return back to Mojave. And shortly, it will be carrying paying passengers from a spaceport which has been developed in New Mexico. And there's a number of other companies that are pursuing that. Virgin Galactic with Bronson have taken that on. Richard Branson, that's the name I was trying to remember, probably familiar with him. He's the financier behind Virgin Galactic, and they've taken on this whole area of space tourism. Advancements in supersonic transportation. The Concorde was not an economical enterprise. It operated for a number of years. A round-trip ticket from France to Washington, D.C. was $12,000. And so that was not the kind of ticket that the average person could afford to fly. And so advancements, and some of the reasons for that is that they couldn't fly over land. The supersonic boom on the ground was a problem. And so flying at this lower speeds, the aircraft wasn't efficient, it wasn't economically viable. So research is going on now to reduce the sonic boom that reaches the ground. Advancements are going on in aerodynamics and propulsion efficiencies to make some of these concepts possible, and I believe they will be certainly within the next 100 years. The SR-72, shown in the middle there, is a concept by Lockheed Skunk Works, a proposal to the Air Force as a replacement to the SR-71. Flying higher, flying faster than the SR-71 did, and having the potential for being both manned and unmanned operations. We'll probably return to the moon within the next 100 years. Hard to say exactly when that'll happen, but that potential exists and research continues in that area, as well as a follow-on to the space shuttle. Future spaceships are potentials, and people will be required to develop those systems and fly those systems in the future. So what does it take to be a part of the future? Primarily, it's a passion and desire, and I described that probably this talk would have better been titled, My Passion of Aviation, and as I mentioned, my hope was to give you a little bit of insight into this and why it's a passion for some of us in this industry and maybe instill a little bit of excitement in you. It takes some level of math and science competency. You don't have to be a rocket scientist, so to speak, to be successful in this area, but it does take some appreciation for math and science. If one is to pursue more rigorous involvement in the field, such as design or engineering work, obviously it requires some sort of technical education in the science or engineering or math areas. Innovation and problem-solving skills. When you think back to what the Wright brothers did, when you think back to what many of those other folks did, Charles Lindbergh, others along the way, Amelia Earhart, what they did and what they accomplished. They were innovators, and they didn't take no for an answer. When somebody said, that doesn't make any sense, we don't think we can do that, and if you look at the history and the literature, you see many, many people that said, we will never go faster than the speed of sound. We will never be able to go into space. And that was all proven wrong by people that had innovation and problem-solving skills. I think it takes an entrepreneurial outlook. Many of the activities that are going on now, whether it be space tourism or commercial operations in space, are looking at the money-making side of this. That how can I put together a business model and make money at this activity? And while in the early years there was a lot of sole inventors and inventions or small teams, 2 or 3 people that made some of these breakthroughs, the breakthroughs that are occurring now require significant teamwork and collaboration skills. And so I would encourage you in any works that you do, whether it be in sports or in projects you work here at the Academy, look for opportunities to work with other people, because that will be a key to the future in any endeavor that you take on. So before I show the video and introduce the 5-minute video here, I want to thank you for allowing me to speak. The future is full of exciting aerospace challenges. Hopefully I've given you a little bit of insight into it and given you a feeling for why I'm passionate about this area. I mean, I work and live aerospace and aviation on a daily basis. You can be a part of this future. It only takes a willingness and a desire, and I challenge you to think big as you prepare for your future. Good luck in your current study and future education. Again, thanks for allowing me to speak here today. I want to leave you first with a quick quote, and then I'll introduce the video. The quote that I leave you with, and it does characterize a lot of what these pioneers did in the advancement of aviation and what we have to enjoy today in that area. Some only dream of success, while others wake up and work hard at it. So I challenge you to consider that. Let me introduce the video. Kelly Johnson, I mentioned him as a prolific designer, a revolutionary designer, an amazing man. He developed the SR-71, one of the 30 aircraft that I was fortunate to fly. I flew it for a number of years as a engineer and a reconnaissance systems officer while in the Air Force. This video was put together shortly after the aircraft was retired from service, and it was a tribute to him. And I think it gives you a little bit of insight into kind of the man he was and the accomplishments that the team that worked for him did. Start at the beginning.
There's just something about the beginning. Dear Kelly, you and I have never met. I'm not a former SR-71 pilot or RSO. I wasn't a member of your design team at the Lockheed Skunk Works or on the assembly line that built the Blackbird. Nor was I a member of the Air Force at Beale, Milden Hall, or Kadena, who kept the Blackbirds flying. I'm not even an airplane buff in the classic sense. I'm just a person that had the privilege of being around your SR-71 Blackbird, and it was an experience I will remember intensely for the rest of my life. There's just something about your Blackbird, Kelly, that words don't adequately describe. Anyone who has been near a Blackbird and felt its presence knows what I'm talking about. It's a feeling in your gut, and instantly you want to be part of it. Part of what I call the Blackbird family. Today, Kelly, you are being honored for your design work on the SR-71, and justly so. To me, the SR-71 is not only your greatest aircraft design, it is perhaps the greatest aircraft ever built. I've heard it said that you considered the Blackbird the most fascinating challenge of your career. No wonder. It was a design that was so advanced that everything that touched it had to be new. New manufacturing processes, new tools, new materials, a whole new approach. You built an operational stealth aircraft a decade before most of the world had even heard the term. It was a design so far ahead of its time that it retired before time could catch up with it. In times of crisis, the Blackbird provided 6 presidents with a unique and critical view of the world. The Blackbird served this country for just over a quarter of a century, and that entire time it stood in a class of one. To me, the Blackbird is much more than a technical marvel. It's an airplane that gets inside you, an aircraft that causes the adrenaline to flow just by looking at it. Kelly, your Blackbird is the stuff dreams are made of. It's the model plane sitting in a young child's room, proof that everything is possible, that the sky isn't the limit. And it's the poster hanging on the office wall of a middle-aged engineer, testimony that yes, even in the real world, miracles do occur. The SR-71 embodies all that excites people about aerospace. Its crew seems part pilot, part astronaut. The Blackbird itself appears part airplane, part spacecraft. The typical Blackbird fan is a cross-section of America. It's your grandfather, your niece, your son. It's the wide-eyed young kid that buys an aircraft book at the National Air and Space Museum. It's the family that traveled hundreds of miles to an air show just to see a Blackbird in person. It's the people on the Air Force Base that stopped what they were doing to watch an SR take off. Everyone, every time, no matter how many times they'd seen it before. And it's the pilot who last flew the Blackbird 20 years ago, who has the look in his eye that says, I flew the best aircraft ever made. The look that can barely contain the desire to get in an SR just one more time and light the burners. When Blackbird 972 made its final record-setting flight to Dallas Airport, I watched the television with mixed emotions. This was the Blackbird's final flight. An aircraft that was the very definition of speed and power would fly no other. But my sadness was tempered by the knowledge that this plane would now truly belong to the nation, coming to rest in the Smithsonian National Air and Space Museum. Now millions would be able to do what I had done, be near a Blackbird, be part of the family. Kelly, in the years to come, whenever I want to experience your airplane's majesty, I will remember the time I spent with your Blackbird, the smell of JP7 fuel, the feel of it on the soles of my shoes, the sound of an air starter wind up, the TEV ignite, and I'll put on the film that we shot during those incredible weeks in 1987. I'll watch it, feel it, be part of it again. Because in movies, Kelly, like in our memories, your Blackbird will fly forever. Congratulations, Kelly, and thank you. Devin Hawker, Assistant Cameraman, Blackbird, the movie.
Thank you very much.